Yeah, we're gonna go over these notes for section 8.4, and then I have a worksheet for you, actually. So let's read through the notes, and I'm gonna help you organize some of them into a table, so it'll be a little bit easier to find things. Okay, so graph rational expressions. You will need to find the vertical asymptotes, the places on the graph where the graph is undefined, values for the variable that make the denominator equal to 0. You guys were doing that yesterday. Okay, you're going to find holes, x-intercepts, and y-intercepts. Then find values around these areas by substituting in values for x and finding the value for y. Plot the points. There are always horizontal asymptotes that are found by comparing there are also horizontal asymptotes that are found by comparing the degrees of the numerator and the denominator. So this is the part where I want to help you kind of make this into a table to make it easier to look at. Okay, if the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. So if the degree of the numerator is greater than the degree of the denominator, you guys remember what the degrees are? Okay, it's your highest exponent on the polynomial in one variable. So if your numerator degree, for example, is higher than the denominator degree, okay, then there's no horizontal asymptote. Now in this case, if the numerator is 1 degree higher, there is what's called an oblique or slant asymptote. And we're going to do an example where we'll find the oblique or slant asymptote. Okay? Okay, then the next part says if the numerator, or if the degree of the numerator is less than the degree of the denominator, so if it's less than the denominator, the horizontal asymptote is y equals 0. So this would be x minus 1 over x squared plus 1 would be an example of that. Okay, and if your numerator degree equals the denominator degree, for example, x squared minus 1 over 2x squared plus 1, then your horizontal asymptote is y equals the leading coefficient of the numerator over the leading coefficient of the denominator. So for this one, it would be y equals 1/2 would be your horizontal asymptote. Okay, any questions? Well, let's look at number 1. We're going to graph. We're going to find horizontal asymptotes, vertical asymptotes, x-intercepts, and if there are any holes. Okay? So the first thing you want to do, is everybody finished with this? I'm going to scoot it up. Okay, the first thing you want to do is factor. I'm going to take the numerator and the denominator, and I'm going to factor if I can. So the numerator here is a difference of 2 squares. Okay, so it's going to factor into a pair of conjugates, x minus 1 and x plus 1. And then the denominator, 2 factors of 5, that will add to be a negative 6. Okay, x minus 1 and x minus 5. Any questions? Okay, so the next step, this is how you find out if there's a hole in your graph. And I'll show you exactly what that is when we actually graph it, but we're just going to find everything right now. So if something will reduce out of the denominator, that's where you're going to get a hole in your graph. So like this x minus 1, that can reduce out. So really your graph is just going to simplify to be x plus 1 over x minus 5. So you have a hole where x minus 1 equals 0, x equals 1. There's going to be a hole in the graph where x is 1. Okay, then your vertical asymptote, you're going to take what's left in the denominator, this x minus 5, set that equal to 0, solve for x, and that's your vertical asymptote. And then the next thing we want to think about is horizontal asymptotes. So if you look at your degrees, they're the same, right? So from the horizontal asymptote, since the degrees are the same, then it's y equals the leading coefficient of the numerator over the leading coefficient of the denominator. So that's going to be y equals 1. Any questions? Okay, so let's, on your graph over there, why don't you separate that into two separate graphs? So maybe we can use the next part on a different number. And go ahead and sketch your vertical and your horizontal asymptote. And I'll do it up here. It's important that you know where the horizontal asymptote, vertical asymptote, and your holes are on the graph because it doesn't show up whenever you use your calculator. But I do want you guys to use your calculator to help you get the general shape of these graphs, and just so you become familiar with them, and looking at their table of values as well. So go ahead and get your calculator out if you don't have it out already, and let's type it in. Look and see what kind of shape it gives us. So I want to put parentheses around the numerator and the denominator, and you want to put in the original equation, not the reduced one. Put in the one that you're given at the very beginning. So x squared minus 1 divided by x squared minus 6x plus 5. Okay, then let's hit graph. And you can see your shape. You can see the graph is split right here. Right, there's two parts, and that's what a discontinuity is whenever your graph stops and you have to, like if I was to trace this graph with my pencil right here, this is all continuous because I don't have to take my pen off the graph at all, tracing that branch on the left side. But to get to the other branch, I have to pick my pencil up off the graph. Okay, so that's a discontinuity point, that asymptote is, because it cuts the graph into parts. Okay, so my calculator doesn't show you the asymptote as a dotted vertical line. That's why you guys need to know where it is. It also doesn't show you that horizontal asymptote. Some of you guys might have that on your calculator, but not everybody. So anyway, I'm going to use this to help me graph my equation. One other thing I want to show you before we start to sketch it though, to figure out where your graph crosses the x-axis, I'm going to take the numerator, it's x plus 1, set it equal to 0, and x is going to have an intercept at -1. That's what that means. Okay, so your x-intercept comes from the numerator, the vertical asymptote comes from the denominator. So I'm going to put a point right there at -1, and I'm going to just sketch my graph. And this branch goes up like this. Alright, so the other thing that I need to put on there is my hole, where x equals 1. So the way that you do that is you go where x is 1. See, there's x equals 1 on the axis. And now I'm going to go down to the graph, and I'm just going to put an open hole there. Okay, so if you look at your calculator, it's not showing that open hole, but if you go to your table of values, where x is 1, it has an error for the y value. So it's a x equals 1 is also a point of discontinuity. Okay, there's not anything for your x value there. Any questions?